So this is Unit 7, Lesson 1, Practice Problems. So let's take a look at this. In this first problem, we're given a 20-degree angle and they'd like to know the measures of x, z, and y. So my 20-degree angle is a central angle. The vertex is on the center A, so I know that an arc is equal to its angle. So I know the arc is 20 degrees. I also can tell that this is a diameter, this line right here, because it goes through the center. So then I know the total is 180 degrees for half a circle. So if this little part's 20, then I know that this y is equal to 160 degrees. So the whole half could be 180 total. And I know I also have 180 on this side. And z is a central angle, and its arc is 160, so that makes z 160 degrees as well. You could have also thought about this as a straight line and got the measure of angle z first and use that to find y. So let's take a look at 2. Find each kind of segment. A diameter, well, there's 2 of them. Remember, a diameter is a chord that goes through the center. So I've got BC, and then I also have GH. Now keep in mind, you can label these in either order, CB, HG, it doesn't really matter. Our next one says a chord that's not a diameter. So that means something with the endpoints on the circle that does not go through the center. So that looks to me like it's DE. And finally, a radius. There's actually many radii in this picture. Pick anything that starts with A. So for example, AC, you could also write it as CA. You've got AG or GA, AH or HA, AB or BA. There's something else in this picture I want to point out that we're going to learn about in Lesson 3. Right here, this is called a tangent line. It touches my circle in one place, and we say that it's tangent at point C. Point C is going to be our point of tangency. So this line with C in it is called a tangent line, and we'll be learning about that. So number 3, identify whether this must be true, possibly true, or definitely can't be true. So a diameter is a chord. So a diameter is a chord. A chord has to have its endpoints on my circle. So this must be true. Every diameter is also a chord. They're just a special chord. A radius is a chord. No, that's false. I'm picturing a radius. It goes from the center to my circle, so it does not have its endpoints on the circle. One of the endpoints has to be the center. A chord is a diameter. Well, this is a possibly. I mean, you could have chords that are not diameters, so it's possible. And a central angle measures 90 degrees. This is another possibly. I mean, it can. You could have a perfect right angle. That's a central angle. My arc's 90 degrees, my angle's 90 degrees, but it certainly doesn't have to be. Let's take a look at the next page. On this page, write an equation for the altitude from vertex A. As a reminder, an altitude is perpendicular to the other side. Notice this right angle mark in my picture. So BC is perpendicular to this line that goes through A. So this is going to be a perpendicular slope problem. So let's find, I want the equation of this line that goes through A. So the first thing I need to find is, let's say what its slope is going to be. So let me get a different color. I'm going to figure out the slope of BC. When I figure out the slope of BC, I know the line I want's perpendicular to it. So the slope from B to C, this looks like it's 1, 2, 3, 4, 5, 6, 7, 8, 9 units in the x direction, and I'm going to call that 2 units down in the y. So it looks like the slope, and this m is not measure. For me right now it means slope. The slope of BC looks like it's -2/9. Okay. So then the slope of the line I want, so the slope of my line is going to be the opposite reciprocal. So let's flip that 9/2, and then let's make it the opposite, so it's positive. So the slope of my line is going to be 9/2, and a point on my line is A. And A looks like it's, it's 2, 1. So A looks like it's 2, 1. So I'm going to use my point slope formula as a reminder. That was my y minus my y coordinate, k, equals my slope times x minus my x coordinate, h. So in this case, it's y minus 1 equals 9/2 times x minus 2. Nice. And then number 5, this was from Unit 6, but I don't believe we covered it. This formula is on your formula sheet. You're welcome to take a look at it. But this was later in Unit 6, before school got closed, and I think it's like lesson 15 or 16 maybe. Okay, ladies and gentlemen, number 6, or I guess it's lesson 16. Consider the parallelogram with these vertices. Where do the diagonals intersect? So first of all, let me just do a quick sketch of this. My vertices are 0, 0, okay, and 8, 0. So let's go over 8. So this guy is 8, 0, and 4, 6. So let's go halfway between these guys and go up to what would be, we're going to call this 4, 6, and then 12, 6. So I'm going to go what I believe to be about 4 more to 12, and then up to this same 6. So 12, 6. So this is just me. It's a sketch. I could get out some graph paper and do it a little neater, but that doesn't look too bad. There's my parallelogram. So something for you guys to know is that the diagonals of a parallelogram bisect each other. In other words, these diagonals intersect at each other's midpoint. So although my diagonals aren't congruent, they do intersect at each other's midpoint. So for this problem, you need the midpoint formula. That's on our Unit 6 formula sheet. The midpoint formula states that the midpoint between 2 points, I add the 2 x coordinates and divide by 2. I find the average of the x coordinates. I add the 2 y coordinates of my points and divide by 2, and that would be the midpoint. So I could do it to either diagonal. If you look in the locker, I've done it with both. For just this video, I'm going to pick one or the other. So I'm going to pick the 4, 6 and the 8, 0. So I'm going to find the midpoint using the point 4, 6 and 8, 0. But I could use either one. So using my midpoint formula, my midpoint is equal to, my x coordinates are 4 plus 8 divided by 2, and my y coordinates are 6 plus 0 divided by 2. So it looks like my midpoint is at 12 divided by 2, or 6, and 6 divided by 2, or 3. So it looks like this midpoint right here is at 6, 3, and that's where the diagonals would intersect, is at x equals 6 and 3 on the y-axis. So feel free to use either coordinates for that. And that concludes our Unit 7, Lesson 1 practice problems. You can refer to the locker for any other questions.